A groundbreaking discovery involving a skull that is 1,000,000 years old has sparked a fascinating debate about the origins of modern humans, suggesting that our roots may extend much further back in time than previously believed. This revelation also opens up the intriguing possibility that Homo sapiens might have first emerged outside of Africa, a notion that challenges long-held assumptions in the field of anthropology. This conclusion stems from a meticulous re-examination of a skull known as Yunxian II, which was unearthed in China. Initially, this skull was classified as belonging to Homo erectus, a primitive human species thought to be a direct ancestor of modern humans. However, after employing advanced reconstruction techniques, researchers now propose that this skull may actually belong to a group referred to as Homo longi, also known as Dragon Man. This group is believed to have a close connection to the enigmatic Denisovans, who coexisted with our ancestors. If this new classification holds true, it would position this fossil as the closest known specimen to the evolutionary divergence between modern humans and our nearest relatives, the Neanderthals and Denisovans. Such a shift in understanding could dramatically alter our perspective on the last 1,000,000 years of human evolution. Professor Chris Stringer, a prominent anthropologist and leader in human evolution research at the Natural History Museum in London, emphasized the significance of this finding, stating, "This changes a lot of thinking because it suggests that by 1,000,000 years ago, our ancestors had already split into distinct groups, indicating a much earlier and more intricate human evolutionary divergence than previously thought." It essentially doubles the timeline for the origin of Homo sapiens. The Yunxian II skull was first discovered in Hubei province in 1990, but its condition was severely compromised, making it challenging to analyze. Initially, based on its age and some general characteristics, it was categorized as Homo erectus. However, the latest research utilized cutting-edge CT imaging, high-resolution surface scanning, and advanced digital techniques to create a virtual reconstruction of the skull. While the skull's large, robust brain case and prominent lower jaw bear similarities to Homo erectus, its overall shape and dental features suggest a closer relationship to Homo longi, a species that recent studies have proposed should include the Denisovans. This reclassification could push back the timeline for the divergence of our ancestors, Neanderthals, and Homo longi by at least 400,000 years. According to Stringer, this raises the possibility that our common ancestor, and potentially the first Homo sapiens, may have lived in Western Asia rather than Africa. This fossil is the closest we've got to the ancestor of all those groups, Stringer remarked. A broader computational analysis of various fossils indicates that over the past 800,000 years, large-brain humans evolved along 5 primary branches: Asian erectus, heidelbergensis, sapiens, Neanderthals, and Homo longi, which includes the Denisovans. Stringer noted, "We believe this study is a significant step toward clarifying the muddle in the middle, the confusing array of human fossils from between 1,000,000 and 300,000 years ago that has puzzled paleoanthropologists for decades." However, these findings contradict some recent studies based on genetic comparisons of contemporary humans and ancient DNA, suggesting that the conclusions drawn from this research may be contentious. Dr. Frida Welker, an associate professor in human evolution at the University of Copenhagen, who was not part of the research team, expressed excitement about the digital reconstruction of this crucial skull. He stated, "If confirmed by additional fossils and genetic evidence, the divergence dating would indeed be surprising. Alternatively, molecular data from the specimen itself could provide insights that either support or challenge the author's morphological hypothesis." The full findings of this research have been published in the journal Science, inviting further discussion and exploration in the scientific community.